Everyone, welcome to the demo of project 3. In this project we have tried using a generative adversarial network to predict the future frames. So in this the project is basically future action prediction using deep multiscale video prediction. Why do we say deep multiscale? Because in order to make a video prediction, like the future prediction, instead of directly passing all the images into the network, we try to do it in the scaling wise. That is, try to scale the images first to 4 cross 4, then 8 cross 8, 16 cross 16, and finally the images are 32 cross 32, which are used for the training purpose. So each and every one scale which is being generated and the ground truths are being compared so that we can get how the classification is being done. So using a GAN, how do we use it? So first step towards doing this particular understanding this project will be what is the data set that we have used. So the data set that we have used is of human actions data set, which is hosted over here, and it has a set of videos for different actions like walk, run, jump. Once you have a data set like of videos containing some videos, like we have over here 90 plus videos, you can convert each of the videos into frames. In order to convert this, you can use convert video dot to jpg, which will help in converting the video into the frames. So for here I have specified the directory in which my videos are being kept. So as if you can see, this is my directory where I have 4 videos. So if I execute this particular cell right now, it will read each and every video and create a directory. So each directory will now contain the video frames for each of these image frames for each of these videos. Once the image clips are being generated, image frames are being generated, we can keep all these image frames, that is each of the individual folders, into another folder, into a common folder, which is basically a train folder, you can say. So let's say if I have a train folder over here, which will contain all the image frames folder wise. So every folder will have a set of 5 plus at least images which can be done for prediction. Similarly, we can create a test database. So in the test clips, I will again have a set of folders, and I can have each folder containing some set of images. So over here. So once this dataset is being ready, then we can start creating the clips out of it. What do I mean by clips is basically I want to create a compressed clips of at least 5 images. So in order to do a prediction, so if we have 4 input into images as input and one prediction needs to be made, so we make the training set using this particular type of recursion. So we can generate the clips for any of the data sets. So this is the Python file that will help you to create the clips. So for now over here, I have given a training um, directory and where I want my clips to be saved and the number of clips that I want to generate. So for instance, if I just want to create one clip, if I run this particular cell, you can see that it tries to fetch the one of the folders from the train dataset and randomly fetches some input images out of it and creates the clips out of it. So once you are done creating the clips for both test and train, so you must have at least like 100,000 clips in both of the folders to get proper good results. So once you're done with this, now we can have the main prediction.py, which will help you to train and test the network. To train the network, you can simply run main prediction.py. You can set your train directory in constants.py, which will have a train directory variable. You can set that to your particular directory. If you want to run testing for some specific directory structure that you have already made, which is containing some set of folders. So like over here, we have a new test 3. So if we see the new test 3 folder over here, it has a set of folders containing some set of images over there. So you can test it like this. Also, you can use the interface to instead of hard coding the folder over here, you can also use the interface, which is nothing but allows you to choose a particular folder. So it must be present in your Jupyter notebook file. So once you're done selecting the folder over here, you can set the parameters like number of recursions, how many do you require. Once you have set the parameters, you can set the parameters over here. And once you're done setting the parameters, we can have the Python this cell running, which will help you to run the predictions only in the test mode. So if I want to check what my outputs are, so this is like a random run through that you can see that it is creating these kind of input output images. So if we had input 4, These were the four, and this is the ground truth that is supposed to be predicted, and this is the predictions that are being made over here. So some other results that you can see are like this. This is a GIF which is already automatically every time created once you are doing the testing or you are performing any kind of operations of testing over there. So if you see if you see, this is the one particular action. The next action has to be with the joining hand, so it is showing like that itself. So these are some of the outputs that like is for the three predictions that we have done. This is for two predictions that are being made, and this is for four predictions that are being made. So definitely for the fourth prediction, it blurs out, but still the sharpness for the at least first to two, three predictions are still pretty good. And we assume that this work can be further extended into many other applications where a lot of 3D spatio-temporal or convolutional networks are being used. So we can implement this architecture over there and try using it. The repository is being hosted on the GitHub, and it has all the documentation over here. The paper that is being used is the deep scale multi-video prediction mean square error, and the repo which has the code over there is being hosted in the TensorFlow over there. It has all the requirements and all the steps are being listed over here if you want to run in your own Python environment, and you can go and visit. Thank you.